Find the number of different arrangements of the 9 letters in the word alligator in which the two A's are together and the two L's are together. Okay, so we'll group A and A, which makes 2 factorial. Then L and L, that's also 2 factorial. And then we have another 7 alphabets left. Okay, now in total, these would make 9 alphabets. But now that we've grouped these two and grouped these two, I'm sorry, we're not left with 7. Hold on, 1, 2, 3, 4. We're left with 5. So that now in total we have 9. Okay, so uh, in total, these would now make 1, 2, 3, 4, 5. This will count as 1, 6. This group will count as 1, 7. So these are 7 alphabets. How do we arrange 7 alphabets? Using 7 factorial. So the arrangements would be 2 factorial times 2 factorial times 7 factorial. And we have repetitions in the question. We have 2 A's and 2 L's. So 2 factorial into 2 factorial in the denominator as well. The final answer would just be 7 factorial, which is 5040. Part B. The 9 letters in the word alligator are arranged in a random order. Find the probability that the two L's are together and there are exactly 6 letters between the two A's. Okay. So we have an A here, 6 letters in between, another A here, and then these make 8 alphabets. So there is another 9th alphabet here. Okay, now it's saying that the two L's are together. So obviously the L's would be somewhere inside the two A's because we don't have enough numbers outside this group to accommodate two L's. Outside, we'll just have one number. Okay, so now let's group this as 1 because A needs to have 6 alphabets inside and the two L's are also together inside. Okay, first I'm going to write the arrangements for this A and A. That's going to be 2 factorial because these are two A's. They have 2 available spots, so 2 factorial. Now I'm going to write the arrangements for these 2 L's. That's also 2 factorial. We have 2 L's at 2 spots. Okay, now let's group these. This will be, we have 4 alphabets and 2 L's joined together because the 2 L's cannot be broken apart. They have to be together. Oops, sorry, I did not realize I was on mute. So let me just quickly repeat what I did. So we get 5 factorial for these arrangements because we have 2 L's combined together. That's 1 and 4 other alphabets with that. So total 5, that makes 5 factorial. And in this spot, we can have I, G, or T, or O, or R. So that's 5P1. So we multiply 5P1 with that. Now what's left is to arrange these two. This full group and this one alphabet. They will have an arrangement of 2 factorial because it could be that whole group and the one alphabet or this one alphabet and then the entire group. Okay, so these are the complete arrangements and we divide by the total number of repetitions, which is 2 factorial and 2 factorial. Okay, so this would give us 1200, which is the answer for part B. Okay. Next is part C, which is find the number of different selections of 5 letters from the 9 letters in the word alligator, which contain at least one A and at most one L. Okay, so at least one A means we could have an A and at most one L, so we could have one L as well, and 3 more alphabets because they're total, we're selecting 5. Okay, this is a collection question on selections, that means combination. A and L could be 2C2, which is just one, so you don't need to write that. And then we have 5 letters. Sorry, the remaining letters other than A and L are, yes, these 5 letters. So 5 out of 3, so 5C3. Then we could have A, A and L and 2 more spots. So this would be 5C3. I'm sorry, 5C2. And these are just 3C3, which is 1, so we don't need to write that. Plus, we could have A and no L at all. So 4 more. So these would be 5C4. And then we could have 2 A's and then no L's. That would be 5C3. So we add all of these together. 5C3 is 10. Plus this is also 10. This is 5. And this would be 10. And I'll add all of them together and we'll get 35.